Welcome to the MS SQL Tips webcast, enabling SANLess SQL Server failover clusters in the Amazon EC2 cloud with DataKeeper, sponsored by SIOS Technology. I'm Greg Robidoux, co-founder of MS SQL Tips and today's webcast organizer. Before we get started, if you have questions, you can submit them anytime during the webcast by entering your questions in the question area in the presentation controls. We'll try to answer as many questions as possible in the time allotted. If you have any technical issues with the sound or screen quality during the webcast, please use the questionnaire to let us know. If you're not already a member of the mssqltips.com community, we invite you to join. You can go to www.mssqltips.com and sign up for our newsletter, read any of our tips, download white papers, and watch any of our archived videos. Also, after today's webcast, please take some time to visit the SIOS website at us.sios.com to learn about all their SQL Server offerings. This webcast will be recorded and archived for future playback along with the slides, and you'll receive a follow-up email with the links. So at this time, I'm going to turn things over to Denny, and he can begin the presentation.
Thank you very much. Good afternoon, everybody. I assume it's afternoon for pretty much everyone. My contact info was there on the first slide. It'll be at the end of the slide deck as well. If you don't have it, I think the slide will be available for download. You can watch the recording and get my contact info as well. So a little bit about me real quick, and then we'll get started. I am the principal consultant and owner of Denny Cherry Associates Consulting. I've written a whole bunch of books at this point. Securing SQL Server is the most recent one that's come out. I've also got a new book that's just about to come out in about 15 days or so, which is called Basics of Digital Privacy. I've written dozens of articles for various websites. I'm a Microsoft MVP for the SQL Server product. I'm an extremely bitter Microsoft Certified Master for SQL Server 2008. I've been a VMware vExpert, and I'm also a Microsoft Certified Trainer on top of all of that. So I do have a little bit of experience, at least, talking in front of audiences about various pieces of technology. So let's go ahead and dive into the deck here, and just talk about some of the availability options available to you in SQL Server today. So we've got a few options. We've got standard hardware, redundant hardware, RAID, and UPS, and battery backups and whatnot that we have to deal with, kind of to build our infrastructure. From there, we start looking at what are our actual SQL Server options for keeping systems up and running and online. So back in the old days, we had some options like log shipping, database replication, and even database mirroring once you got into the SQL Server 2005 space. And these are all good, but these aren't great, and they don't work all that well sometimes when dealing with certain environments. Once we get into actually wanting things with automatic failover, well, now we start needing to look at things like database mirroring in high safety or synchronous mode, depending on what verbiage you want to use. So now we've started to look at the option for failing things over. The nice thing here so far is we don't have any sort of redundant storage, or rather we have redundant storage. We don't have any single point of failures. Big downside to database mirroring, though, is things don't fail over as a group. We don't protect things like logins. We don't protect system databases, system objects. None of these things are protected as part of our database mirroring configuration, because database mirroring is just at that one database. So if we want to start looking at failing things over kind of in groups, we need to start looking towards our failover clustering options. So that's when we start looking at our traditional failover clustering, now called AlwaysOn failover clusters, or even our multi-site clusters as we start getting into looking at site-to-site availability and the needing to be able to fail over from one site to another. So there's a whole bunch of options available here, but when we start thinking about just working in Amazon, and working in the EC2 environment, so what are those options for failover in EC2? Well, we can use database mirroring, but again, we've got all the same problems we just discussed. We don't have system objects being replicated. We don't have logins being replicated. It doesn't support all the features of SQL Server. If you want to use file stream, for example, that's not an option with database mirroring. It's just not supported by Microsoft. They didn't have time to build that into database mirroring, and by the time it was time to start working on that, availability groups had been introduced, so there was no point in trying to add it to database mirroring because database mirroring was going to be deprecated. So another option is log shipping. Log shipping is great, but again, we have all the same problems with database mirroring, and then we have some additional problems built in. Larger amounts of data could be lost because we're based on, how often we're going to be running our log-based backups. We've got other potential problems along the lines of, just the fact that it's log shipping and it's just a pain to manage. There's no automatic failover options. You could probably script some automatic failover options in log shipping, but it wouldn't be pretty or easy, and the risk of split braining the system with some sort of automatic failure on log shipping is extremely high. And then you end up with two production systems, and users have the potential of writing into both of those at the same time. So the third option we have available in EC2 is really always-on availability groups. These were obviously introduced in SQL 2012 as an enterprise-only feature. And so we can use these in EC2 because there's no shared storage requirement. It's very easy to get set up. But the big downside here is we've got to work within the requirements of Amazon to get these availability groups set up. And that means it's got to be SQL Server 2012. It's got to be Enterprise Edition. And you've got to have some understanding of how availability groups need to be set up so you can get that failover. You've also got to have your apps certified from your vendor or whoever is building your app that it's going to work on always on, because there's some downsides to working in an always on environment as well. So I talked about some of the problems with database mirroring already. The biggest one is that it's deprecated. It is going to go away eventually. So we're going to have to deal with that at some point where it is going to drop out. Now, mirroring is going to be around for a little while, but people are shifting away from it already simply because, it has been deprecated. So, we don't want to be relying on something that isn't going to go away. Another big downside is with database mirroring is you only get the asynchronous database mirroring with that Amazon license that you get as part of your EC2 subscription. So when you go buy an EC2 box from Amazon, you can say, hey, I want SQL Server included with my box, and it comes with a license. Well, the license it comes with is standard edition by default. So if you want synchronous database mirroring, which means automatic failover, well, now you've got to bring your own license. So because we're using asynchronous, we have no automatic failover option. That's just not available. Microsoft does not ever have an automatic failover option available on any asynchronous technology. That's why you don't have automatic failover with log shipping. That's why if you're looking at always on availability groups, you've got those asynchronous copies. You can't automatically fail to them. Microsoft's done this intentionally because they want to make sure that they're never going to cause data loss by doing an asynchronous failover accidentally. So with log shipping, same problems, no automatic failover. Then we've got this problem of RTOs and RPOs as well. We've got a potentially long window for data loss. And that's because it depends how we've got our log shipping set up as to whether or not we're going to be able to get things rolled forward correctly and how much data we're going to lose. Also, we've got the potential for a long recovery time while our logs are rolled forward. This is something you always need to think about when planning your HA or DR strategies is in the event that we do need to do this failover, how long is it going to take for us to roll everything forward? So with log shipping, if you say you've got your secondary server rather an hour behind, you have to at that point roll that hour's worth of logs forward. Well, on a really busy system, that could take a good 20 minutes. So you've now got a 20-minute outage while you're rolling things forward. This is obviously not a particularly good situation to be in because you want to make sure that you've got the system up and running and smoothly moving forward as quickly as possible. Because while yes, we can technically take systems down in the event of a DR failover, our customers don't want the systems down. That means we don't want the systems down. So we want those systems back up and running as fast as possible. So when we look at always on, there's some issues here, when it comes to working with this in EC2. So the first thing is it's an enterprise feature, so that you are going to have to bring your own SQL Server license to make this work. This means it's not cheap. The Enterprise Edition, always on availability groups. We're talking about multiple servers. We're going to be doing, a lot of licensing, so extremely high cost here. Even if you wanted to use, say, SQL Server 2008 or 2008 R2, you're still looking at buying a whole lot of enterprise licensing, even if you need to go back to older versions for some reason. Obviously, this does require SQL 2012 or higher, so we have to deal with that. We need to keep in mind that when dealing with always-on availability groups, we do have some resource scheduling problems. We do, always-on works great on really big boxes. Your VMs at Amazon EC2 don't necessarily have a whole ton of cores available to them. So that means we don't have a whole lot of schedulers available to us. Well, always-on does not work well on boxes that are running on really hot CPUs. So we need to make sure we have overhead available for always-on if we're going to try and fail over. If we don't set that up correctly, always-on is just going to fall over and the entire environment's going to come down. Just like database mirroring, just like log shipping, always-on does not cover things like master, MSDB, your logins, your SQL agent jobs, etc. These are all kept outside of your always-on availability group environment. One of the big, most annoying things that I see when it comes to always-on is the fact that there is no support for distributed transactions. This is a big thing that's missing for a lot of applications that need to move into always-on, is that DTC is technically not supported with always-on. So if you do need to run distributed transactions against a database that's set up within an always-on environment, they may not work as you expect them to. So that's something you need to keep in mind. So if you need distributed transactions for your application, and there's a lot of applications out there that do, then always-on availability groups is simply not going to work as an option. So we need to look at something that's going to allow us to do something more like traditional failover clustering. So one of the places we can look for that is with DataKeeper. So DataKeeper's product from SIOS. It's fully integrated with Windows Server failover clustering. So the nice thing there is it's supported by Microsoft. So it works with a wide variety of applications, SQL, Exchange, SharePoint, a whole bunch of other stuff. You can use it on standalone boxes or in VMs. Conveniently enough, Amazon EC2, just a bunch of VMs. So the nice thing here is we're doing block level replication. So we're doing the same thing we'd be doing if we had a SAN, but without needing to stand up our own storage in EC2, which realistically you can't do. So you can, this gives us that same kind of block level replication. All SIOS is doing is capturing the writes to the disk and pushing them out across the network to another box. There's not a whole lot of memory that's being used by the DataKeeper application. The memory footprint is incredibly small for what it does. It's a really fine-tuned application as far as what sort of workload workload overhead it's putting on the box. Obviously, with SQL servers, we want to be very, very careful about what kind of other software we're running on our servers. So, there's a lot of data replication processes out there that eat a ton of RAM. This is not one of them. The data is compressed as it's sent over the network, so it is optimized for pushing data from site to site or availability zone to availability zone for multi-site clustering within EC2. Depending on what sites you use or what availability zones you use, you've got options for synchronous or asynchronous data movement between those two sites. So if you've got, if for example there was two data centers that EC2 had that were relatively close to each other that you wanted to use, you could use synchronous data replication to to harden that write at both locations at the same time. If you wanted to go across the country or around the world to provide really high level of data protection, for example, a European data center to a North American data center, you can do that as well because it does support an asynchronous data movement between machines. The interface, nice and simple to use. It's a nice, simple MMC interface. I believe Tony's going to show that to us in a little bit, but it's fairly straightforward. I mean, if you can use SQL Server, if heaven forbid you're as old as me and you can remember SQL Server 2000, God, that's depressing to say. You'll remember what MMC looked like. It's very easy, very straightforward. I was able to figure out the interface for SIOS in all of about 20 seconds. Figure out how to get data moving between boxes and get data replication set up. So it's fairly straightforward. So we've got a nice bullet point list here of features of kind of how things are going to be laid out, and it's really a nice quick feature list to compare availability groups, failover clustering, and then failover clustering with DataKeeper. So when dealing with DataKeeper, one of the biggest bullet points that people love is that first one, standard edition. So that right there is a no-brainer. Everybody loves being able to do stuff with standard edition and not requiring enterprise edition. Like I mentioned, distributed transactions, we need to deal with that in a lot of applications, and that's just not an option in availability groups. We can have an unlimited number of databases. We are just talking about SQL Server clustering at this point. That's one of the beauties of the DataKeeper product, is that it's simply failover clustering. So however many databases SQL supports, 32,000, whatever, if you've got that many, reevaluate how you're setting things up. But it's however many databases you've got in the instance, that's what DataKeeper is going to support and replicate for you. System databases are all covered. You can have more than 2 nodes in your failover configuration. It gets a little trickier to do in Amazon, but that's problems with Amazon more than anything else. You can replicate data other than SQL if you need to move other data. If you've got a file network share that's attached to your failover cluster that an application is writing stuff to, that can all be configured to failover with DataKeeper as well and can be replicated from site to site. The replication is extremely efficient. That's because we've got data compression built into the DataKeeper product, so it's compressing that data as it shoots it across the network. We're wiping out the SAN as a single point of failure. This is one of the biggest complaints that a lot of people have with traditional failover clustering, is that unless you've got 2 SANs stood up next to each other replicating data back and forth, you've got a single point of failure. We don't have that here with AlwaysOn failover clustering with DataKeeper, because we've got 2 local disks presented on those VMs, which are then replicating back and forth to each other. And we've got multi-site cluster support. So that's obviously something that's a big deal with, in today's world of, we need to protect ourselves from that availability zone at Amazon going offline. And that's a very real thing that has happened. I mean, Amazon has taken the availability zones down a few times, usually by accident. So we never know when we're going to lose that availability zone. So we need to make sure that we can have servers in multiple availability zones. Obviously, we have no failover clustering options natively, so we can't do that with native tools. We have to have a third-party tool to make that work, and DataKeeper is the tool to do that in. So there's a nice little animation here that kind of shows how it works and how the whole process works. So we've got 2 VMs stood up here, one on the left, one on the right. We've got our SQL Server instance running on the one on the left, and SIOS's replication through DataKeeper pushing data over to that server on the right. All the data being written to their own independent local drives. So it's, sorry, this isn't VM, this is physical. This is a physical boxes with local storage. So if we click over to the next slide, we'll see that the configuration in Amazon is fairly straightforward. And here we've got 3 availability zones. One with our production SQL Server in it. The second availability zone in the middle there, that's actually got our file share witness, because we need a box for quorum. We're not going to be using disk for quorum here. We're going to be using an actual VM for that. And then the third availability zone, we're going to run our secondary instance, or our passive node of our cluster, as it were. So the reason we want that file share witness in a separate availability zone to the 2 SQL servers is because we don't want it in either one of those zones, because then we'll end up split braining. If we have it in a third availability zone, and there's a minimal cost for network traffic to do that, I believe, but we're talking pennies a month probably. You know, if we've got this third box out in a third availability zone, when it's actually time for a site to fail or a box to fail, the file share witness needs to be somewhere other than those two boxes to confirm that things are actually going to work. As you've seen, the failover happens fairly easily, and data is simply replicated back across to that primary box once it comes back online. And then once it's back online and it's fully in sync after it rebooted or whatever problem it recovered from, at that point we can fail back fairly easily just using normal SQL Server, normal failover clustering. We just fail the entire instance right back. So there's some great reasons to look at DataKeeper Cluster Edition as our solution. Nice thing is, it supports geographical clustering when using two VMs and two different Amazon sites. So this is a really important, really nice thing that that I was talking about. Our replication is only limited by the speed of our network. Amazon has done a really good job building the network within their environment, and so it's the network at Amazon is going to be significantly faster than any of the disks that are available. The biggest, most important bullet point is this next one right here. Microsoft supported. This is a Microsoft supported app. It's got a certified for logo sitting on it. We saw it a couple of slides ago. So it's if there's a problem with SQL Server and you call Microsoft CSS for support and open a ticket with them, they're going to see that SIOS DataKeeper Cluster Edition on there, and they're going to be perfectly okay with supporting that server. So that's one of the most important things out there when selecting a data replication provider, is always make sure that it's going to be supported by Microsoft. Because if it's not, and you call Microsoft for support, all bets are off as to whether or not they're actually going to help you. So this is fully cluster aware. So the nice thing here is it simply plugs into the cluster, and as far as the cluster is concerned, it's shared storage. It doesn't really know any difference between the cluster aware SAN storage that you get from like EMC, NetApp, etc., and DataKeeper Cluster Edition. As far as failover clustering is concerned, it's exactly the same. And all we're doing at that point is turning EC2's native disks into clustered resources. It actually sounds fairly straightforward, and that's really because it is. So some tips and tricks here if you're going to be doing failover clustering within EC2. The first one is you're probably going to want to select two sites that are relatively close to each other. There's a NorCal site in Northern California, and there's one in Seattle. Those I would consider relatively close to each other as far as Amazon's concerned. And just the reason why I do that is just to minimize the network latency, because anytime you can take latency out of the equation, that's a good thing. You're going to want to increase storage speed by adding multiple disks and striping across them. This is a standard Amazon best practice whenever you want to increase the number of IOPS that you can get out of a VM in EC2 Cloud. So this isn't a SIOS specific recommendation. This is just a general recommendation whenever we're dealing with Amazon. Amazon disks by default are not the fastest things in the world, but if you get a whole bunch of them, that'll give you a whole lot more I/O capacity because you're then on a lot more spindles, and then create a standard Windows stripe across them, and that'll give you the ability to write a lot faster than you would normally. So another option is to increase the storage speed by adding disks and putting one database file per file group on each disk. So this way, instead of striping across the files using the Windows software RAID, you simply do it in SQL Server, instead. When setting up the SIOS software, make sure that you've got both of the VMs configured exactly the same. You want to make sure you've got the same number of disks and the same size disks because you need the same I/O profile to basically be able to support the same amount of work on both sides. If you can't support the same amount of I/O on both sides, you're going to end up with your secondary box being slower, and that could hurt your performance if you're in a synchronous data replication mode. So I know SIOS has done a case study recently on a customer in EC2. So Tony, can you tell us a little bit more about that?
Yeah, definitely. Thanks, Denny. So we've got a number of customers who have deployed our products up in Amazon EC2, and one in particular was a software company, and they create software for retailers and distributors. And what they did initially, what they were looking to do is they wanted to move a 3-tier application up into EC2. So they have a web tier, an application tier, and a database tier. And the big gap that they had in the current architecture was that they needed to ensure high availability as they deploy the SQL 2012 backend behind their application. And prior to moving this infrastructure, this application stack up into Amazon, they were doing this all in their own data center on physical servers. So the team was already familiar with SQL clustering, doing this on physical servers with shared storage as the backend, and they wanted to have a similar level of protection, similar functionality up in EC2, and at the same time, they didn't want to have to relearn, how to cluster, use a completely separate technology. They wanted to, leverage the existing skills that they already have, but simply kind of transfer their configuration, transfer their skill set up into a cloud environment. So what they ended up deploying was essentially what Denny showed you on that previous slide, was a 2-node Windows Server failover cluster where the different nodes lived in different availability zones for maximum protection. They're actually doing a multi-instance SQL cluster, so running one instance on the first cluster node and a different SQL instance on the other cluster node. Essentially, each is a backup for one another. They followed the best practice and deployed a third instance in a third availability zone for maximum protection here, so that if you lost an availability zone, you wouldn't be losing cluster quorum. You wouldn't lose a node and the file share witness potentially at the same point in time. And they did that by deploying a Windows Server failover cluster and augmenting it with DataKeeper Cluster Edition to enable the real-time block-level data replication as part of a traditional failover cluster solution. So if I move on to the next slide here, as far as some of the requirements that they were looking to work with, we've mentioned some of those already. One of the big drivers of moving up to this cloud environment was eliminating all the CapEx associated with deploying this new application. So they didn't have to purchase new servers, purchase a SAN, not to mention the maintenance that comes along with that, power costs, cooling costs, and so on. So by placing this workload up into the cloud, they were able to achieve a lot of those benefits, but while at the same time, they weren't okay with sacrificing high availability in an environment that at the end of the day they really couldn't control because it's outside their data center. So after they deployed this 2-node failover cluster, they were able to achieve an improved total cost of ownership. They didn't have to purchase any new hardware. By deploying a DataKeeper-enabled cluster, we also refer to it as a SANLess cluster because the different nodes don't have shared storage. Now, storage is no longer a potential single point of failure. It actually, provides you with a higher level of availability because you're eliminating yet another component in the cluster as an area that could take down the entire cluster. And this is all very easy to set up. I'll show you a quick demonstration here, but through the wizard-based interface that Denny mentioned before, the entire cluster was set up and configured in well under a day. The DataKeeper piece of this is very simple. It's literally a 3-step wizard to set up a mirror and have it be registered as a cluster disk. So if you've ever set up a traditional shared storage-based SQL cluster in the past, you already know probably 95% of what it takes to get this all done. The remaining 5% is just the installation of DataKeeper and the setup of the mirrors to get data replicating between the systems here. So again, this very similar slide to what Denny showed, but this is exactly what they set up. They have node A, they have node B. They're actually doing a multi-instance SQL cluster where SQL Server instance on both nodes of the cluster. And again, if they have a failover of the SQL instance takes place from one node to another. And in this scenario, DataKeeper maintains a bitmap file on a per mirror basis that tracks what data has been modified and what data hasn't been modified. So when the failed node comes back online, an automatic and partial resync of the data takes place to get the returning node up to speed and with an identical copy of the data as quickly as possible. It's a very efficient resynchronization process here. So with that, let me give you a quick demonstration and we'll show you what a DataKeeper enabled cluster looks like here. So I've got a simple two-node configuration, and let me bring up Failover Cluster Manager. So again, the beauty of this is, once you move to the cloud, the way that you ensure availability is the same as you've done it traditionally in your own data center with failover clustering. And here I've got a couple of different clustered resources. So for anybody who set up a cluster, this is going to look very familiar to you. The main difference is if you go and look at the storage pool, the storage section of your cluster. So in a traditional shared storage-based cluster, you would see cluster disk 1, 2, 3, and so on. Microsoft would call those physical disk resources. And those would represent the shared LUNs on your SAN. Well, when you're doing this without shared storage, you're doing this up in the cloud, you don't have shared storage. And that's where DataKeeper fills that gap by providing cluster-aware mirrors. What I have in this particular cluster are two different DataKeeper volumes. I've got DataKeeper Volume E and DataKeeper Volume F. So each of these look like a piece of cluster storage, but in reality, I've got an equally sized E volume on each of my systems, and I've got an equally sized F volume on each system, and DataKeeper is doing the real-time replication. So the way that you get that into the cluster is very simple. Here's DataKeeper's MMC snap-in, and I'm looking at the server overview report where I can see the servers that are part of the cluster called primary and secondary, and I can see the different volumes that I've got, two of which are already being replicated, so I've got mirrors set up already for E and F, and I've got this extra R volume, and we'll go ahead and set up a new mirror for that right now during our session here today. And we do so by clicking Create Job, and we'll give this a name. We'll call it R Drive. And it's a three-step wizard. So step 1, you select your source machine. Step 2, you select your target machine. And on step 3, you select some mirror options, such as the mode of replication, so synchronous versus async, compression, throttling, things like that. So here I've got my source machine. We're going to select that the primary server is the source of the mirror. If you've set up multiple network interfaces, and up in EC2, you have the ability to assign multiple network interfaces to your instances. So you want to have multiple network interfaces so that a single virtual network interface is in a potential single point of failure. And when you have multiple network interfaces, you can select specifically which one you want to use for replication. So it's always a best practice to separate your replication traffic from your user and your application traffic. So I'll select this backend network, and then you select the drive letter that you want to replicate. Step 2, you select your target side of the mirror, and it's pre-populated the screen for me automatically. This is simply a two-node cluster. It knows what the other server is. It's selected the network card on the same subnet, on the same network, and it's selected the same drive letter. So generally, you don't have to change anything on the second screen. Finally, I can select my mirror options, and this is where I decide, if I'm doing synchronous or asynchronous. So if I'm setting up a cluster within a single region, but my nodes are in different availability zones, well, the nice thing about that is an availability zone is no longer a single point of failure, but within the same region, between different availability zones, you essentially have local area network type connections. You've got a very high speed, low latency. So you can do synchronous data replication there. If you were doing this between completely separate regions, maybe between San Francisco and Seattle, as Denny was mentioning earlier, well, in that case, you might want to do asynchronous because you're going over more of a WAN type connection, and there's generally going to be some greater latency there. And that's it. So you select done. If on that previous screen, if I did want to turn on compression to minimize the amount of data that goes across between the source and target, because between regions you are going to be paying some transfer charges here, we'll minimize the amount of data that goes across. So the mirror has been successfully created. So my R drive is replicating from source to target, so from primary to secondary. And because DataKeeper is cluster aware, it's asking me if I'd like to take this newly created mirror and register this with the cluster as a cluster disk. So I'm definitely going to say yes. And now if I go back into Failover Cluster Manager, I can see I've got this brand new piece of cluster storage. So my DataKeeper volume R was registered with the cluster. So it looks and it feels and it acts like a piece of shared storage. It looks and feels and acts like a LUN on your SAN. But in this case, I've set up a cluster in the cloud. There is no SAN. Each instance in Amazon, which is just a VM again, is using its own local independent storage. And now you can achieve native failover clustering by leveraging DataKeeper, which is providing cluster-aware, real-time, block-level data replication here. And just like you would expect, if you want to move a resource from one to the other, perhaps I want to move one of these resources to the other node. So I can simply, just like we would on the ground with a shared storage-based cluster, you simply move the resource to the other node in the cluster. And if I take a look at the details here, it's going to do a failover just like you would expect. And as part of that failover, it's also going to fail over the DataKeeper disk volume, which is telling DataKeeper to switch the direction of data replication. So you notice how I did all of this through Failover Cluster Manager. So really at this point, you really don't need to go back into the DataKeeper UI. Your life will live in Failover Cluster Manager just like it did when you were deploying SQL clusters in your own data center. So it's really DataKeeper sitting there behind the scenes, providing that cluster-aware real-time replication and the protection levels and high availability levels that you've come to expect in traditional SQL environments here. If we go back and just take a look here at the DataKeeper UI to show that it actually switched over the mirror, I can see here my F volume, where it used to be a source on the server called primary. Well, now it's a target. So at this point in time, I actually have different drives replicating in different directions. So I've got E and R replicating from primary to secondary, and I have F replicating in the opposite direction from secondary back to primary. So you can have different drive letters replicating in different directions. It doesn't have to be a purely active passive cluster. If you want to do a multi-instance SQL cluster, different instances on different nodes, you can certainly do so. Very common to do. So that concludes the demo portion of our webinar here today. I guess what we're going to do next is just open it up for questions and go from there. So Greg, I'll turn it back over to you.
Okay. Actually, Tony, can you see the questions that were asked? If you look at the questions tab.
Let's see here. Let me stop my screen sharing here, and I'll be able to see the control panel again. Okay, great. So yeah, we've got a couple of questions here. So we've got one question that says, in order to use DataKeeper, do the clustered servers need to boot from SAN? No, the answer is no. So DataKeeper doesn't have a requirement on the type of storage that you use. So you could boot your servers from a SAN. You could boot them from a SAS or SATA drive that lives inside the server. That's up to you. And as far as the volumes that you would then cluster, any block device will do. So the disk that you replicate could be in a cloud environment, could just be like an EBS volume that you've attached to the virtual machine. In the physical realm, it could be a SAS or SATA drive, it could be an SSD, it could be a PCIe-based flash card, or it could even be a LUN on, on a SAN or Fiber Channel or iSCSI, maybe where you have two different SANs from two different vendors, so the SAN replication isn't an option. So as long as the storage is simply presented to the operating system as a block device, so basically go into Windows Disk Management. If the disk shows up there, partition it up as you like, give it a drive letter, and that's good enough for DataKeeper. So you can even mix and match hardware if you needed to, if we were talking about doing this in a physical environment. There's a question about domain controllers up there. So yeah, if you were doing a native Windows failover cluster, so Windows Server failover cluster has a dependency on Active Directory, so you would probably want to put a domain controller in each availability zone as well. If that's something that you can't do, there are other ways to accomplish that, and we could always follow up with you to go in some of the specifics on that. We have another question about if network interfaces are all virtual, is there really that much of an advantage to assigning multiple interfaces on a cluster node? So I guess so yes and no. If all the virtual interfaces end up going through the same virtual switch, or if they're all going through the same physical network card on the host machine, then it's not buying you as much. It'll still help you if, for example, there's an issue with inside Windows and from inside the VM, you have an issue with the network card. But if there's any problems outside the VM, it's probably not going to help you. Now, if that's not the case, and you actually do have the different virtual NICs on different vSwitches on different physical NIC ports, then that'll definitely provide you with higher levels of availability. Let's see here. We have a question about where does the control of SQL Server take place, and does SQL stay online on both nodes for all instances during failover? Okay, great question. So the failover and the control is handled by native Windows Server failover clusters. So the failover clustering, that's part of Windows Server here. And in general, a clustered resource is only going to be active on one node of a cluster at a time. If you want to do an active-active type configuration, well, what that really means is one SQL instance on node A and a different SQL instance on node B, each as a backup for one another. And when a clustered resource moves from one node to another, it is basically stopped on one node and started on the other. Let's see here. A lot of great questions here, so I'm trying to make sure we can get to as many of them as possible here. We have a question that says, can you show us the steps needed to start SQL on the mirror side when SQL on the primary side is down? Great question. So the beauty of this is you don't have to do this yourself manually. If this is a clustered environment, when one node goes down, the cluster is automatically going to fail over the SQL database to the remaining node in the cluster. And when it does that, it's automatically also going to tell DataKeeper that new server that's about to come online needs to become the new source of the mirror. So when the failed node comes back online, it rejoins as the standby system, and the data replicates back. Another question is, is DataKeeper just for Amazon, or can you use it with regular physical servers? So great question. You can definitely use it. You can really use it anywhere. DataKeeper works in both physical and virtual environments, and as Denny mentioned before, EC2 is just one type of a virtual environment you could deploy applications in. So if you want to do this in your own data center, and you want to take 2 or more physical servers and form a cluster, and you don't want to make an investment in a SAN, you just want to use local storage, then this could be a great solution for you as well. Let's see here. Let's see if there's any other questions. There's some duplicate ones in here. Question about, does this solution work with Amazon Elastic Block Store, EBS? Yes. So you want to make sure, so the answer is yes, and that's how most people set this up with EBS volumes, because you want to make sure that the storage is persistent across reboots. There are types of storage where it's, if you reboot it, you take the instance down, it's not going to be there. You definitely don't want that to happen in a SQL environment. You definitely want to be able to reboot a system and have all your SQL data still there. So EBS volumes definitely supported. That's pretty much the standard way of how people deploy this there. And another reason why you want to have persistent storage is so that when the failed node comes back online, DataKeeper can do a partial data resync. If the volume was blown away and it was empty when he came back, we'd have to do a full resync of data each and every time, which is definitely not very efficient. We have a question about how is the software licensed, both for physical and virtual servers. So here at SIOS, we keep things simple. It's licensed on a per per system basis, so per cluster node basically. So if it's a 2-node cluster, that would be 2 copies of DataKeeper. You would need to install DataKeeper on all nodes involved, because at any point a node in the configuration, its role could switch. It could be a source and an active cluster node right now, and maybe later if a failover happens, well, now it's a target. So the DataKeeper software is running on all nodes in the configuration. So DataKeeper, there's a question about, do the applications need to be cluster aware to use DataKeeper? So DataKeeper itself, we honestly don't care what the application is. DataKeeper is doing disk level, block level replication. So you simply, as we saw in the demo here, you tell DataKeeper which drive letter you want to replicate, and we'll do that for you. Whether you put SQL data into that drive letter, or PDF files, or images, or custom application data, that's completely up to you. As far as the failover goes, if you want to make this highly available, then generally, yeah, you do want your application to be cluster aware. And if it doesn't have a native integration with clustering, clustering, and Denny, feel free to chime in here if you like, but failover clustering does have the ability to run like generic scripts or stop and start services that might not be natively cluster aware. So.
Yeah, if you've got an app that you want to cluster, as long as it can run as a service, you can really cluster it. The easy example in SQL Server would be if you had some reason where you wanted to cluster integration services, so that it was always only running on whatever node was actually running your SQL Server instance. There's people out there that have done this. It's not a recommended situation, but it's an easy example that everybody who works with SQL Server can wrap their head around. You literally just go into Failover Cluster Administrator, right-click on the resource group, and say add generic script or add generic service resource, and then simply tell it the name of the resource that you want to cluster, and that resource is now clustered. So basically, as long as whatever app you're using runs as a service, it's incredibly easy to cluster it, and it will then just fail over with the cluster. If you've got an app that's not running as a service, if it's just a command line app, you can still do that. There's a lot of flexibility in failover clustering for the kinds of resources that you can set up. This includes generic applications, VB scripts, PowerShell scripts. These can all be set up as clustered resources. So basically, when the cluster starts, the application would be started. If the application were then to fail, failover clustering would detect that failure, and it would then trigger a failover to happen. So if you had some homegrown app that needed to be run constantly and it needed to be highly available, you could definitely use DataKeeper to move the files for the work area that application uses, or the data files that application uses between nodes, and then just set that application up as a clustered resource.
Excellent. Thanks, Denny. Question, is there an equivalent for Linux? The answer is yes. So we've been focusing here on Windows and SQL in today's webinar, but SIOS does have Linux products as well. So if you want to do data replication or high availability on physical or virtual or cloud systems, yeah, feel free to reach out to us. Our website is us.sios.com. Send an email to info@sios.com, and we'll definitely help you out. Question about, does DataKeeper use compression? So that is a fully supported option out of the box. By default, compression is not turned on, but as you saw when we created the mirror in the demonstration, it was simply a slider bar that you can just drag from off all the way up through maximum compression. Usually the sweet spot is somewhere in the middle. We have a nice balance of bandwidth savings versus CPU cycles used to compress and uncompress the data. Let's see here. Question about, so if a node goes down and the cluster fails over to the other node, well, then the original node comes back. Do just the changes get replicated back, or does the entire volume get replicated? The answer is just the changes. So with DataKeeper, we maintain a bitmap file, and that bitmap file, when the mirror is, that bitmap file is used to track the delta between source and target. So in that scenario where you have a failed node, DataKeeper and its bitmap file would be tracking, well, okay, block 7 was written to and block 45 was written to and block 433 was written to, so that when the failed node comes back online and the mirror automatically resumes, we do just a delta, so a partial resync takes place. Let's see here. What triggers the failover? Good question. So DataKeeper itself doesn't trigger any failover. That's all done by failover clustering. And a number of things could trigger a failover, whether like a machine died or a resource that's being protected in the cluster has failed, like an IP or the SQL instance or a cluster disk. So a number of things, it's looking at all these different layers, and a failure of anything, if it can't be brought back online, can trigger a failover. A question about the witness server. So we talked about in that a shared nothing cluster configuration where you have that file share witness, does that need a DataKeeper license? No, it does not. So the system that's the file share witness, the file share witness is just a Windows system, and you create a simple file share. So create a folder, share it out with the network, and give the cluster appropriate permissions to write to that file share. So all it is just a shared folder, essentially. So DataKeeper is not installed, and you don't need a license for that. I think we're getting closer to the end of the questions here. Okay, so follow up with a non-cluster-aware application. Can we use it to replicate to a warm VM? Now, again, DataKeeper is disk-level replication, so you can replicate data for any application. And if you just wanted data replication, but you didn't want to actually set up a cluster, we've been talking about here today DataKeeper Cluster Edition, but we do also have a DataKeeper Standard Edition, which would be standalone data replication that's not integrated with the cluster. That might be something you'd be interested in if you simply want to replicate data from A to B, but you don't want this as part of a cluster configuration. Let's see here. Can you replicate between physical and virtual systems? Most definitely. So again, you just want to make sure that the servers are as identical as possible. It's always a best practice to make sure servers have the same patch levels, same version of the application is installed, things like that. But they can be on different hardware. One could be physical, one could be a virtual machine. You just want to make sure that from a storage perspective, as Denny mentioned in one of his slides, that the drive letters match, the volumes are the same size, or the target needs to be the same size or bigger, I should say. And you want to make sure that the storage on that virtual machine isn't too slow. If otherwise, with a synchronous mirror, it could slow down your writes on the source, or an asynchronous, if your source is writing twice as fast as your target ever could, your mirror might never catch up. So you want it to be fast enough, I'll say. Let's see here. Question about the bitmap file again. What's the limit of the bitmap file? So there is no limit. I often get asked, well, how long can the mirror be interrupted, or how long can the mirror be down, or how big does the bitmap file grow? And my answer is the bitmap file doesn't grow. It's not like a log. It's a statically sized file. Think of it more like an array or a pointer, where we're just flipping bits on and off inside of a file to keep track of which blocks are in sync, which blocks are out of sync. So to put things in perspective, the bitmap file is very small. On a 1 terabyte, if you're replicating a 1 terabyte volume, the associated bitmap file for that mirror is like 2 or 3 megabytes, and it never grows over time. It's always going to be that fixed size. Great question. We have a question about different disk sizes and what's supported there. Again, this is the size of the data set isn't so important. What's most important is the rate of change versus your bandwidth. So whether this is a 100 meg volume or a 1 terabyte or larger volume, you name it, the size of the volume will certainly affect the initial synchronization time, because when you first set up the mirror, the data needs to get from source to target. From there on, what really matters is how rapidly are you writing data to that volume, so we call that rate of change, versus how much bandwidth do you have between the source and the target side of the mirror. And you definitely want to make sure that your rate of change fits within your bandwidth. And if it doesn't, you might turn on some compression, or you might look at getting some increased bandwidth or things like that. But rate of change should fit within your bandwidth. Question about, can you read data on the remote or the passive databases? So DataKeeper, in one of our more recent releases, we now support taking what we call target snapshots. So what you can do is you can take a snapshot of the disk on the target side of the mirror, and you can get access, actually full read-write access to that to run reports, to do SQL backups, things like that. Basically offload that particular workload from your primary node using a point-in-time snapshot of your data. So, common use cases would be like a nightly reporting or nightly backups. If you want to do that off of your passive system, you could do that by taking a snapshot, performing your activity, and then dropping the snapshot. So we've got a target snapshot feature that can address that. We have a question about, so if a database is corrupted, do you think it will replicate corrupted data to the mirroring server? So, replication and backup are different. You still need to have a backup solution, because when data changes on the source, it gets replicated over to the target. So, for example, if somebody goes in, if they delete a file from a volume, or if they delete a row in the database, that deletion is going to be replicated as well. So you still do want to make sure that you've got the appropriate, backup procedures put in place, regardless of, and that's true even if you had a traditional shared storage cluster as well. HA and replication are separate from the backup processes that you should have in place still. And we have a question about, does DataKeeper have a cache that needs to or can be cleared for maintenance reasons? Nope, there's no type of a cache or anything. The closest thing I can think of to a cache would be our bitmap file, and that you don't need to ever touch the bitmap file. That's just maintained internally to track, the delta between source and targets there. So I think we've come to the end of I think we've addressed most, if not all, of the questions that came in via the chat. We've got about 2 minutes left here, so let me actually bring up, show my screen once more here. So we've got Denny's contact information back up on the screen. I don't know, Denny, if you want to say anything before Denny or Greg, say anything before we wrap things up here today?
Yeah, I just want to thank everyone for coming. I know it's always rough to get an hour out of your day at the end of the week, so thanks everyone for coming. If questions do come up about SIOS or anything else about SQL Server, feel free to shoot me an email. You've got my email there. I'm always happy to answer questions when they come in.
Okay, I guess we can just wrap things up then.
Sounds good.
All right. Well, thanks, Denny, and thank you, Tony, for all that great information. And also want to thank SIOS Technology for sponsoring today's event. The webcast was recorded, and everybody will receive a follow-up email with links to view the archive, and that should be set up hopefully by the end of this week, if not by early next week. I want to thank everybody for attending today, and when you exit the webcast, please just take a few minutes to fill out the survey. The feedback helps with both today's webcast as well as future events. Thanks again for attending, and hope you all have a great day.